Yeah, so welcome back here. .NET Conf Day 3 Community Day. This session is Security First .NET, basically all things application security you can do with .NET and C# using GitHub. So if you read the session description, you can tell that was generated by my good friend Copilot, notably by the usage of all the M dashes there. But I did do a search and see there's 17 other M dashes in the content as well. So kudos for all the presenters for working smarter, not harder. As mentioned, I'm Chad Bentz. I've worked for GitHub for about the past 4 years. My title just means I get to work with you and our customers, trying out all of our new application security features in GitHub. I still identify as a .NET developer, but I've been focused on application security for about the past 15 years as well. So really happy to be here and excited to give back to the .NET community. Been to so many sessions, and it's been a really great conference so far. Just a quick intro here of what we're going to be talking about. We'll talk about GitHub, C#, the state of AppSec, what's going on here. We're going to talk about insecure dependencies, what you can do to remediate and prevent them from continuing to get into your backlog. How easy and costly it is to accidentally ship a secret and what GitHub offers to protect you here. And then we'll wrap up with how you can prevent, detect, respond to vulnerabilities in the code that you are writing. And then hopefully, if some time at the end, we'll do some Q&A so that we can answer your questions. So we'll jump right in, just talk about the GitHub platform. So GitHub just continues to be the home of open source development and now AI-powered development as well. We just wrapped up our annual developer conference, GitHub Universe, at the end of October. And as part of that, we deliver our annual Octoverse report that gives us stats on all of our platform. Some of the highlights from the report, .NET usage is continuing to grow at impressive rates. So C# continues to be in the top 5 used programming languages just year over year there. The headline really is that .NET usage stays strong. C# repos grew 10% year over year, which is consistent with enterprise and gaming and other tooling ecosystems. But that also suggests that AI features are being integrated into .NET workflows, and we're not stagnating there. We're gaining new contributors, over 130,000 new developers this year, putting us near 1 million developers active in .NET on the GitHub platform month over month. But what about application security? So we've kind of seen this momentum. We're shifting from like a notify me to let's just patch things automatically within guardrails. We've seen repositories that define Dependabot behavior in a Dependabot.yaml more than doubled this year alone. So 846,000 total repos have that Dependabot.yaml, and that's increased 137% year over year. Broken access control overcame injection attacks to become the top CodeQL alert overall, flagged in over 151,000 repos. For C# specifically, though, we continue to see security logging and monitoring failures take the top spot for CodeQL alerts. We're also seeing faster fix times. So in 2025, we saw 30% faster fixes for critical vulnerabilities, with 26% fewer repos having critical alerts. This acceleration is pretty much happening at scale too. So the average fix time shrinking from 37 days down to 26 days in total. And to be really transparent with y'all, like this is the clear remediation trend that GitHub is after. Like for too long, application security tooling has always been really painful for developers, adding additional work and stress to your jobs. But the clear message we have for you is that if we find something in GitHub, we're going to give you a solution, the fix. It'll be right there along with the issue. So it's really exciting to see that come to fruition and just be represented in the numbers we're showing you here. Let's just jump right into some demos. We're done with the slides now. You can follow along or watch back here to enable some of these features. I'm just forking public repos. I'll link to the repos I'm using at the end as well here. We're going to start out just digging into insecure dependencies. These will be like vulnerabilities, not in your code explicitly, but ones that are pulled in from your third-party dependencies. Let me open up my Visual Studio. You may have noticed your NuGet CLI, NuGet.org, Visual Studio. Anytime you pull in a dependency that has a vulnerability, you might have seen this yellow banner that comes across your Solution Explorer here. If you're navigating the dependency view, you can see we're getting alerted to vulnerabilities. If you go down to your error list, those same vulnerabilities are shown to you front and center. So we're trying to give you all this information right in your IDE as you're developing. But let me take you over to GitHub and show you how GitHub can really be that last line of defense, prevent pull requests coming in. Maybe not everybody's using the same IDEs. and how we can use our code review process to get those things front and center as well. So I have a repo here with some intentionally vulnerable dependencies, as it's named. Forked it from a public repo. I'm going to take you right into the insights view. So this is where we have what we call our dependency graph. Just going to click this big green button to enable it. It's not enabled by default there. What it's going to do, I have to refresh my screen here, is it's going to walk all the manifest files we have in the repo. So in the case of .NET, we've got NuGet manifests in our CS proj files, package JSONs. We've got our central package management, directory props JSONs. And in this repo, we also have some GitHub actions. So all that inventory of what we're seeing in the repo is listed here. The caveat is this isn't the full picture, right? When we do a NuGet restore, a lot of extra dependency information comes down when we run a build, the exact version we use, all the transitive dependencies we use. So you can see this big old hint here, GitHub saying, you've got more to do here. So you as a repo owner can go to the settings tab and then scroll down to advanced security. These is where all of our security features live. So, well, number one, if you're an open source developer, turn on private vulnerability reporting. Click enable here. That's all you have to do. This would allow a security researcher, if they find a vulnerability in your application, to basically reach out to you privately, report that. You can work on a fix with them. And when you're ready to disclose it responsibly, you can do that with a fix with the support of GitHub. We're here to help you there. So definitely recommend you turn that on. The next one we were just talking about, detecting those transitive build time dependencies. One button clicked here to enable that. What that's going to do is every time you touch one of your manifests in those CS projects, it's going to run a build, run a NuGet restore, and report that full dependency graph for all your directs and transitives. Next, for Dependabot, this is really gives us a few different features here. I'm going to suggest you go right down to grouped security updates and you click enable. So what that's going to do is it's going to turn on Dependabot alerts. So vulnerability reporting for everything we see in the graph. It's going to give you security updates, which would bump you through a pull request to the next non-vulnerable version of all those packages. And then group them together, meaning we'll just send you one big pull request with all the fixes right there for you. Run your unit tests, run your integration tests, make sure everything's working, and just merge that pull request in. All your vulnerabilities from your third-party code is gone. So it should be that easy. Lastly, there's one other feature here, Dependabot version updates. To enable this, you just need that dependabot.yaml file we talked about earlier in your repo. The idea here is this is more centric around just keeping all of your dependencies up to date, even if they're not vulnerable, just as kind of a best practice. You just need to suggest the ecosystem to run this on, NPM or NuGet or all the other ecosystems that might be in this repo. You can list them out in this YAML. All kinds of different settings you have control over. Head to the docs here that's linked, and that will give you all the settings. Commit that to your main or master, whatever your default branch is, and that will basically fire off Dependabot to keep you up to date. All right. So now that we turned on that submission, let's head to GitHub Actions because it runs an action every time we make a change. I just made a change, so you can see actions running there. So I'm going to head to the first one that ran when we turned it on. Remember, we said this is going to run a NuGet restore. So if I go all the way down to, right, it's getting the code for the repo into this GitHub action, and it's running a restore on all of our projects with a solution if it's here. End result of that is we have all of the dependencies that were used on disk here, and you can see the number of dependencies that were explicitly referenced in our project, 14. But total of components found is 118. So the vast majority of the dependencies you're using, even in .NET, are all coming transitively down through NuGet. So without that information, doing vulnerability reporting is not giving you the full picture here. So let's head back to the Insights tab, go to our dependency graph. And now remember we had like 20 or so here before. We now have 181 total, both direct and transitive. You can see NuGet packages, the name, the version you're using. If it does say a transitive on it, you can hit these. Actually, given this big hint here, you can view transitive paths. Okay, I got it. You can click show paths, and this will show you the dependency that pulled in the transitive. And more importantly, if there is a vulnerability on that, you can click here and see, oh, there's a Dependabot alert. So we can click into that. This will take you to our security tab. This might be new for you if you've never seen this. And it will take you into the Dependabot view, filtered down to that package we were just looking at. So this is kind of the anatomy of a Dependabot alert. So what the alert is, the package we found it in which project, it's a transitive, here's that graph. More importantly, what versions are vulnerable? All this information is curated by our GitHub security lab team in what we call the GitHub advisory database. So the advisory database is all about curating actionable information. Which packages are impacted, which version fixes it, give you all the details, the severity, predictability score of if it might be exploited in the next 30 days, pulling forward CVE information. And of course, if something's wrong with this data, click here to send us a pull request, right? We're open to fixing this information if it's not accurate or up to date. If you want to fix it, click this big green button to fire off a Dependabot security update. We're running that grouped update in the background, so that would be spinning as well here. So we probably wouldn't want to do this a one-off. What we might want to do, though, is go take a look at our backlog. So here's the backlog. In this repo, we've got 12 Dependabot vulnerabilities. That's not a ton. I've seen thousands. I've seen tens of thousands. So if you do want to get drilled down and maybe the more important packages you want to focus on, there are some filters here. You can filter down to the scope. If it's a dev dependency that's only like impacting your IDE versus if it's a runtime dependency, would be the opposite. Like this is a package you're deploying out into your production. You can filter down to that. And then that same EPSS score we mentioned, the predictability score, if it's going to be potentially exploited, we can maybe filter down to say, if it's got a greater than a 2% chance of being exploited, give me the list of alerts. So there you've taken that list from 12 down to 3. These are probably your most important ones that you'd want to go patch faster than the other ones if you needed to do that more as a one-off, if you've got a really large backlog. So that's really awesome to view your backlog, but like how would we prevent these from getting into our repo as new vulnerabilities? So while this repo continues to spin, I'm going to head back to the repo I forked from because I've got already a pull request out here where I've added a vulnerable dependency. So now I'm a project maintainer. Imagine somebody sending me a pull request and they're updating my package manifest to pull on a dependency. So I go look at the files change here to do a code review, and like this just like makes my eyes gloss over with all the information here. I want to show you a really cool button to click. Go to the manifest and click this display the rich diff. What that does is gives you a visual view of all that diff on the manifest, the packages. It gives you green if it's added, yellow if it's modified, red if it's being deleted, the version, when it was released, the number of usages, the license types, and then more importantly here for our security discussion, if there's any known vulnerabilities. So just pulling in this one dependency's got 2 high severities, a medium severity, a moderate severity. So all that information is visible to you here. What you can also do as a project owner is you can turn on a feature we call dependency review. So it uses that same diff and just looks to see if anything in the diff there is vulnerable or if there's any license types. And you can then set up a policy. If it doesn't meet your policy, we can put these red X's here and tell you it's failing to meet your policy. Drops right into your pull request here, puts a comment. If it does find a vulnerability, it gives you information about what the vuln is. Let's go peek at this one real quick. This is, again, taking you right to our GitHub advisory database. This is a really nice one because the REST-Sharp team had a vulnerability, and how this got reported to them was through that private vulnerability reporting we were talking about earlier. So I'm going to click this link and go right to the REST-Sharp repo. And on that repo security tab, you can see they've published an advisory, which package is vulnerable, what the fix is, and you can see they worked with some security researchers. We give them credit. We want to encourage this behavior to do responsible vulnerability disclosure. They worked together. Whenever the patch was ready, they asked GitHub to create the CVE and roll this out to anyone using Dependabot that was dependent on any of these versions, less than 107 of REST-Sharp in this scenario, would have then got that Dependabot alert basically in real time if they had the usage there. So that kind of just highlights how that rolls up. And we were talking about dependency review. So that is done through GitHub Actions today. You can see the GitHub action ran as a check task and it failed because it didn't meet our policy. In this case, the policy out of the box is just if there's any vulnerability, fail. In this case, we had a moderate. But if we go look at the workflow file for this one, the GitHub action, just a YAML that basically runs on any pull request, and it's a one-liner. And then you can set a policy in this case, put the comment on the pull request, what severities do you want to fail on, what license types do you want to allow or deny, and then remember, we were doing that automatic submission of the transitive dependencies through what we call a snapshot, so a point-in-time snapshot of the build. This basically says, hey, wait for that, because that takes a few seconds to run and do the NuGet restore and publish it up to the graph. This will basically spin wait for as many seconds as you describe here for that snapshot to come in, and then use that in the diff. So that's a really awesome way that you can set this up. The easy button to get this set up is if you go to the security tab, you go to code scanning, there's an add tool button, and we have what is like a curated security marketplace. Dependency, you search for dependency. There's a marketplace item out here called dependency review. You click configure, it'll write that YAML file for you for dependency review. Just commit this to your repo, and then again, put whatever your policy is down here, and then you're good to go. Before we wrap up here for dependency management, I'll just show you what one of those grouped updates ends up looking like since this repo has been enabled here for a few months. You can see this update is bumping 7 packages in one pull request. So again, it's trying to go to the next non-vulnerable version if it can. This uses NuGet under the covers, so it can bump parent dependencies, it can bump child dependencies, and if it can't, it will just pin the versions, so it will make sure that transitive that's used is not vulnerable. You can see that Dependabot PR here is updating this directory packages props XML here using central package management on this repo. So that's fully supported now by Dependabot, and a really awesome feature. So go turn that one on. All right, let's shift gears a little bit and talk about secret leaks. So this is like when you're accidentally leaking API keys, tokens, and other secrets. This risks security breaches, reputation damage, legal liability at a pretty mind-boggling scale when we're talking about GitHub. So at GitHub, we were detecting more than a dozen accidental leaks every minute since 2024. GitHub Secret Protection is a feature that was created basically to combat this head on. GitHub has partnered now with over 150 plus, I think we're up to 186 providers currently, that we work with them to understand over 415 different secret patterns and tokens. And when we detect those in public repos as a leak, we do notify those partners through a partner program. So if you are minting tokens as part of a product you're working on and you have a very specific format, reach out to GitHub. You can join our partner program here. So if we do find a token, we'd reach out to you and let you either revoke it or alert your users. The majority of folks would just revoke these things because something had to be done here, right? Malicious users are basically scraping these credentials off of GitHub faster than you could even use them in your application. So back in 2023, we allowed our users to opt into a feature called push protection. And think of push protection as like a Git pre-receive server-side hook. It actually runs in a quarantine phase before pre-receive. And that just means that GitHub can detect secrets coming into github.com, block the commit. We'll look at the commit for any secret and then allow the users to basically revoke that commit before it even gets leaked publicly into GitHub. So back in February of 2024, we actually turned that on by default for all users. So let me do a quick demo just to show you what that ends up looking like so you're not surprised by it. I was working on a feature in my application. I'll show you here in a minute. I wanted to basically integrate with Slack. So I set up a Slack webhook URL. I created a Slack channel for it. I copied this secret. As you can see, it's like a URL with Slack webhook here, but it's got a token kind of in the URL format. So Slack is one of our partners. We understand what that token format is. I'm going to take you down into a new application here, a different one from the one we were just looking at. But it does some integration with other social networks, and now it's integrating Slack. I asked my buddy Copilot to help me integrate and introduce this feature to turn on Slack integration. I gave it my webhook URL because I needed to test that. You can see Copilot in the ID here was giving me some hints that like, hey, this isn't really right. You shouldn't be doing this. There's a hard-coded credential here. You should probably move this to a secret score for production. So Copilot gives you some gentle hints that you shouldn't be doing what we're doing here ultimately. But either, I got distracted, I forgot, or maybe I accidentally go and try to actually commit this code. As you can see in my app settings development JSON, I've got that webhook URL here locally in my commit history here. So if I go and I try to push that secret up to GitHub, as soon as I do that push, you can see the push failed to the remote repository. So we sent the commit up, but before it got anywhere publicly leaked on GitHub, we failed the push. So you see as in the output window here, the source control Git window, GitHub push protection failed the push. The push cannot contain secrets. We have a link to the docs. You can learn more. Uh, we detected that Slack URL in this commit in this file on line number 9. And if you really, really needed to get the secret pushed out to your repo, you can click this link and you can basically, as a developer, self bypass push protection. Maybe you've already revoked it and it's just going to be a sample. Whatever your reason is, we allow you to get that in there. 9 times out of 10, though, that's not what you want to do, though. Just put like a sample token and not a real token instead. But you can now go to your Git history. I'm inside Visual Studio 2026 here. You go to Git, view branch history. You can see here's my latest commit that I just tried to push up there. But since it's not there, we just go to the commit before it and choose reset, but keep our changes. So that will take the commit, roll it back. I guess if you go here and do a refresh, you can now see that commit is gone. And now I can go back here and instead of hard coding this kind of in a public settings file, we could put this into an environment variable or a key vault or somewhere more secure than the Git history for a repo. So yeah, that's really awesome. It's as I said, like on by default, and you don't need to do anything to get that. But just to give you some hints there on what it would look like if you do get a push block. Let's shift gears one more time here and talk about vulnerabilities in the .NET code you write. So I'm going to head to that same repo we were just looking at, but I'm going to go to the GitHub view of it. You can see it's a pretty big mono repo. It's got a mobile MAUI app, a web Blazor app, a control web API here in .NET Core, and a shared NuGet library that I published out to NuGet. So we're going to head back to our settings on our repo and go back to advanced security. Scroll down a little bit below Dependabot, and you'll see code scanning. So this is where you can configure CodeQL to do static analysis on your repo. Choose setup, choose default. This is our easy button. We basically are detecting which languages are in the repo we can scan. We'll give you a choice of which queries you can run. I'll click this link and show you the docs in a second. This is going to run on every push and pull request to your default and your protected branches and on a weekly cron job. I'm just going to click this green enable button and send it off to work. To give you a little more description about what's going on when I click that button here. So it's running a GitHub action right now, but I'm going to dive into the docs here for C# analysis that we do with CodeQL. So CodeQL is GitHub's first-party semantic static analysis engine to look for vulnerabilities in the code you're writing. The way it works, you see we're talking about queries here. So we actually turn your code into data. So as we see every file in your repo, we extract those files out into a database. That database contains the abstract syntax tree, control flows, data flows, and we bundle that all up into a DB. And then we take our security queries, we execute them back against the database of your code. The result of that is vulnerabilities. So this doc page shows you all the queries we run, which CWEs they relate to. If they're in that default suite, we also have an extended suite, which have lower severity vulnerabilities, lower precision, and then which queries we will suggest fixes for, which is pretty much all of them at this point. So we can head back to that repo. We can go to GitHub Actions. We can see CodeQL is still running here. It should just take a couple minutes to run. Again, it's detected all the languages in our repo, but within a couple minutes, it will scan all of these for vulnerabilities. Let's head back to the repo I forked from because this one has actually completed. And let's maybe just open a pull request and see what this would look like as new PRs are added into your application. So I've had, again, my friend Copilot open up some intentional vulnerabilities here as a pull request. It does it with some additional like hints that saying, hey, you did ask me to introduce a vulnerability. Do not use this for production. But it's really nice that Copilot can kind of be a little bit of a red teamer here with you if you're doing some vulnerability research. I personally use Copilot for that all the time. But you can see here, if we keep scrolling down, the files that Copilot introduced here knowingly introduced some vulnerabilities. And now that we're running CodeQL, like we set up that default setup, it's running on the pull request, we can see that it's detected some vulnerabilities. These vulnerabilities are of high confidence because we can see these coming in from a user-provided value. This is our API tier on a controller coming in from the path variable from the query. If we click Show Paths, we can see where it comes from, the source, we can see how it flows into the sink. In this case, the sink is a logger call, taking user data unsanitized and jamming it right into our logs. Like I mentioned, when we find things, we want to fix them. So we're giving you a Copilot autofix hint here that says, hey, you should be escaping user input, not allowing them to do like log forging, injecting of new lines and returns um, into that log, because they could kind of simulate their own logs being injected there. And we'll give you a fix. What we're suggesting to do, sanitize that user input before you call the log. If you like that, you can just take a commit it right to this PR branch. If you need to make some changes, click the edit button. That'll let you edit things. Or you can always kind of do this and apply this commit into your local IDE. Take the diffs that we're suggesting here and test it out locally as well. Another vulnerability, uncontrolled data in a path expression. We've got the same kind of paradigm here. Data flowing in, you can see flowing into a file read all text. Kind of same idea. Maybe that's not the best thing to do. We should probably be doing some consideration of not allowing like dot dot slash coming in. Even the fix is suggesting we should be looking in a specific folder and then sanitizing that input. So you can see that the Copilot autofix is kind of giving you this information here right in the PR. Again, you can fail the pull request if that fails for CodeQL, and it'll give you that information that you've got vulnerabilities coming in that we want you to fix. That's all great for new vulnerabilities, but let's go take a look at the backlog. Actually, let's go back to our other one that I think if we check now, we can see this one's finished. This is my fork. 1 minute ago, we've detected 6 vulnerabilities in our backlog here from that initial scan. You can see it's the same log forging issue where user data coming in is not sanitized when it calls the logger. This one's a little deeper of a data flow, but you can see we give the developer all kinds of information about the vulnerabilities and what they are, links to the OWASP top 10, severity scores. But I've got a lot of these. I can go and I can click Copilot here to generate an individual fix, which is very similar to what we saw in the PR there. But since we have 6 of these, maybe the right thing to do is head back over into our IDE and let's ask Copilot to fix these for us. So one of the really cool things you can do is turn on the GitHub MCP remote server here. And this does support code scanning as a tool that you can use to either get or list the code scanning alerts. To do that, go to your MCP JSON and just opt into the tool for code security or Dependabot or secret protection, or just choose the all tool set in the API URL. So here we can just ask it to list me all the injection vulns in this repo, and it will go out and use that remote MCP call to call the GitHub API for all of the vulnerabilities that apply here. And it's going to pull forward all that context, all the vulnerabilities, the files, the line numbers, all the data flows from source to sink. That's going to pull all that data back here into my IDE. And now my Copilot context is really, really good here. So maybe the right way to fix this would be like, let's implement this in my shared project as a common injection sanitizer and fix it everywhere. So we can either ask Copilot to do that or use agent mode and just do it. But in this case, like it's now got all that context that it can go iterate through all of those vulnerabilities and come up with a really solid fix. Again, you can see all the files that we know those vulnerabilities exist in already coming from that prior scan we did in github.com, now pulled forward into this context. And you can see it's found my shared library, my NuGet package, and it's implemented a class called log sanitizer, a method called clean that's, again, doing that return new line injection, preventing tabs. You might want to prevent whatever if you're logging as JSON as your logger, maybe you don't allow JSON. And then it's going out to every file and sanitizing that input. So that's what I wanted to show you. That's it from me. Go out and implement this on all your GitHub .NET repos and stay safe and secure out there. This link at the bottom is has all the information about the repos I was at, links to GitHub docs, GitHub blogs, all about these features. So take a look at that if you have a chance.